All right, today we're going to cover the question number 5 from the 1999 exam, and this appeared on both the AB and BC exam. I'm classifying this as a type 3 question, which is the type where you're generally doing some sort of function analysis given it the graph. Either you're given the graph of the derivative or you have information about a function defined by an integral of the graph. So we'll start off with part A here. It's asking us to calculate g of 4 and g of negative 2. So right off the bat, they tell us g of x is 1 to x, f of t dt. So g of 4 will be evaluating the integral from 1 to 4 of f of t. So they're asking what is the area enclosed or the accumulated area from 1 to 4. And if we look at the graph there, 1 is at a high point of 4. That's at 1. And then at 2, we drop to a height of 1. So there's a trapezoid that we need to calculate the area of, as well as from 2 to 4. Now 2 to 4, we have two triangles, one that is above the axis, so that would be positive accumulation, and one that is below the axis, which would be negative accumulation. Now, since these two triangles are of the same size, they will cancel each other out. And all we need to do is find the area of the trapezoid. So the area of a trapezoid is the average of the heights. So this height right here was at a height of 1, and this height right here was a height of 4. And multiply that by the width of the trapezoid, which is 1. So g of 4 is equal to 5 halves. Okay. That's the first part. The second part of the question asks us to evaluate g of negative 2. So g of negative 2 would be the integral from 1 to negative 2 f of t dt, which we can calculate going backwards, recalling that accumulated area above the axis would be negative, or if we wanted to, and I think this is totally acceptable, we can switch the order of the boundaries by making the integral negative. And now we're working forward, and from negative 2 to 1, we have a triangle that has a base of 3 and a height of 4 units. So that triangle there, we can use the triangular formula for 1/2 of the base times the height carry along the negative, and we get a massed area of negative 6. There's our two parts for part A. When it comes down to grading for part A, you get 1 point for the first question and 1 point for the second question, or second part of part A. Okay? So let's move on to part B. Part B says find the instantaneous rate of change of g with respect to x. So they're asking us to find g prime of x at x equals 1. In other words, g prime of 1. Well, we've already established that g of x is the integral from 1 to x of f of t. That's given to us. So now we can find g prime of x to be equal to f of x, and that's using the fundamental theorem of calculus. The derivative of the integral is f of the top times the derivative of the top minus f of the bottom times the derivative of the bottom. So, very easily, g prime of x is the function. So g prime of 1 is going to be f of 1, which we can see from the graph is 4. Okay. So part B, pretty straightforward. You just had to remember that the derivative of a integral defined function, you apply the fundamental theorem of calculus to. So part B is worth 1 point. Get 1 point for getting the correct answer there. Moving on to part C. Find the absolute minimum value of g on the closed interval. So absolute minimum on a closed interval should inspire you to do the candidates test. And the candidates test says that the absolute extrema will occur at either critical values or at the endpoints. So first step that we need to do is we need to find the critical values. And the critical values occur where g prime of x equals 0. And in the previous problem, we learned g prime of x is equal to f of x. So here we're going to say critical values occur where f of x is equal to 0. And the only location that this occurs at is at x equals 3. So when we run the candidates test, the absolute minimum is going to occur either at 3 or at the endpoints. So we need to find g of the endpoints and g of 3, which is the critical value. Now g of the endpoints, negative 2 and 4, we've already established, were negative 6 and 5/2. So now we need to find g of 3, which would be the integral from 1 to 3. And the integral from 1 to 3 would be 5/2 for that trapezoid plus 1/2 for the little triangle. So we've got that trapezoid shape right here, oops, plus the little triangle right here. Okay. So this is equaling 5/2 plus 1/2 is 6/2, which is a total of 3. So find the absolute minimum. The absolute minimum is going to occur at negative 2. So g of x has an absolute minimum of negative 6 at x equals negative 2 on the interval negative 2 to 4. Looks like my cat's paying this. Hi, kitten. Say hi to the camera, kitten. Camera shy cat. Alright, let's pause this. Okay, so for part C, there's going to be worth 3 points, and one of the points comes from analyzing the interior. So in other words, finding the critical value and figuring out where the function is at that point. And then 1 point comes from analyzing the exterior, i.e. the endpoints. And then your final point comes from identifying what the absolute minimum value of g is. So the absolute minimum value is negative 6. On to part D. In part D, they tell us the second derivative of g is not defined at x equals 1 and x equals 2. How many of these values are the x-coordinates points of inflection on the graph G? So we're looking for points of inflection on the graph G. So a POI, or a point of inflection, exists on g of x where g prime prime of x changes signs and g of x exists. So we're going to look for a spot where g prime prime of x changes signs. Draw a really quick sketch here. This is the graph of f. And we're going to use this to explore g prime prime. Now, we'd established that g prime of x is equal to f of x using the fundamental theorem, and consequently we could say g prime prime of x equals f prime of x. So if I ask the question, where does g prime prime change signs, I am asking, where does f prime change signs? And f prime will change signs where f of x goes from increasing to decreasing, or vice versa. So f prime of x is greater than 0 on the interval -2 to 1 because f is increasing. So consequently, we can also say that g prime prime is greater than 0. Similarly, we can say g prime prime is equal to f prime of x, which is less than 0 on the interval 1 to 2, because the function f is decreasing from 1 to 2. And the last interval, g prime prime, f prime of x, is also less than 0 on the interval 2 to 4, and that's this interval here. So f is decreasing, so f prime is negative. I'll put that in here because f is increasing, because f is decreasing, and because f is decreasing. So we've analyzed the graph, and now they're saying a point of inflection exists where g prime prime changes signs. Well, g prime prime change signs from positive to negative at that location of 1. So how many of these values are x coordinates of points of inflection? So only one of the two values is a point of inflection, and that would be at x equals 1. And then just to round out our explanation, only one, x equals 1, and that's because g prime prime of x changes signs, and g of 1 exists, whereas at x equals 2, g prime prime of x does not change signs. Therefore, no POI at x equals 2. Okay. So this one is worth 3 points, and you get 1 point for making your choice at x equals 1. Your second point comes from showing that there is a point of inflection at x equals 1. And then your third point comes from showing there is no point of inflection at x equals 2, for a total of 9 points.